A wonderful day, grade 8 students. I am your science teacher, Miss Robilyn Ibina, to guide you as you learn about the particle nature of matter and its properties. So let's go and explore the world of science with new concepts and ideas that can be used in our daily life. In today's video lesson, you are expected to describe the particle model of matter, illustrate the arrangement of particles in the three states of matter, explain the attractive forces in each state of matter, use the particle model of matter to explain the properties of solids, liquids, and gases. Now, let us assess your prior knowledge about today's topic. There will be 5 multiple choice questions that you need to answer. Read each item carefully and select the letter of the best answer. Write it in your science notebook, but we are going to check it after your post-assessment at the end of the lesson. Are you ready? Let's begin. In your first class, you learned about the physical properties of solids, liquids, and gases. You also have knowledge about what makes up the matter and its classification. In this video lesson, you will learn more about the particle nature of matter. Crucial to this undertaking is the use of a model as a representation in understanding the behavior and properties of matter. Have you tried blowing air inside a balloon? Why is it that air can be compressed? Have you had any experience being injected by a nurse with medicine using a syringe? Have you noticed how the plunger of a syringe moved once it was pushed or pulled? Now take a deep breath. What happened? Now try creating a mental picture of what you see as particles of air inside the balloon or a syringe. Are there spaces inside the balloon? How about a syringe full of liquid? Can you say that there are spaces in between the particles of liquid? If you're going to make an illustration, what will it look like? As a kid, perhaps you have had a happy experience playing in the sand. Does the sand really flow like water? To answer these questions, Let us explore and discover the particle nature of matter. What is particle? When you created a mental picture of what is happening at some level beyond what you can see, you are constructing a model. A model in a scientific sense is something that is used to represent an idea. It can be conceptual or physical. It is used to explain concepts. The particle model of matter is one of the most useful scientific models because it describes the arrangement of particles in all three states of matter. The model was a result of many discoveries about the particle nature of matter. Particles refer to any atoms, molecules, or ions that compose matter. By using this model, you can explain why liquids and gases flow but solids do not, why some solids are harder than other solids, and why do liquids and gases behave that way. This model also forms part of the kinetic molecular theory of matter. Let's be reminded of some important details about matter. 1. All matter is made up of tiny particles. These particles are too small to be seen by the naked eye. All particles of one substance are the same, as shown in the two examples in letter A. Different pure substances have different particles, which is represented in letter B picture. Take note that the particles have empty spaces between them, empty meaning nothing. The size of these spaces determines the states of matter. So looking at the pictures, which state has the most or widest space? Which has the least? If your answers are gas followed by solid, your answers are correct. Another key point to remember is that the particles of matter have attracting force that keeps the particles together. The strength of the attractive forces varies from one kind of matter to another. This time, let's arrange the strength of attractive forces of these states of matter in an increasing order. Which particle or which state of matter has the strongest attractive force? Which has the least? If your answer is from gas to liquid then followed by solid, your answer is correct. So, the least attractive forces are those in gases, and the strongest attractive forces are in solids. Another key point is that the particles are in constant motion. Solid particles tend to vibrate or rotate in a fixed position, while liquids and gases move from place to place. Let's note that this motion is related to the kinetic energy of particles. The kinetic energy of particles directly depends on the temperature. So, as the temperature increases, the speed of the movement of these particles also increases. If we are going to compare these three different states of matter, which has the highest kinetic energy? If your answer is gas or gas particles, you had a good choice. Let's highlight the properties of the three states of matter based on the particle model. Solids like a gold ring or diamond, they have strong intermolecular forces, maintain a definite shape and volume, do not flow, incompressible. Incompressible means the particles cannot be more closer together. This time for liquids like water, there is a strong attraction between particles but not as strong as in solids. The particles are not held in a fixed arrangement, they are free to move. A fluid is any substance that can flow and take the shape of its container. Liquid particles cannot be compressed. For gases, like the air we breathe, neither has a definite shape nor volume. Gas particles move rapidly in all directions. The particles of gases are very far from each other. Compared to liquids and solids, the attractive forces in gases are much weaker. Gas particles are highly compressible. Here are other important details for solids, liquids, and gases. You can pause the video to focus more on the contents for each state of matter. Let's check if you have learned something. Answer yes if the statement is correct, and answer no if the statement is incorrect. Let us start with the first statement. Solids have fixed shape and volume because the particles are held tightly together due to very strong attraction between them. Hence, they cannot move apart. Answer after 3 seconds. Did you get it right? If yes, very good. Let us proceed to the second statement. There are strong forces between the particles of solids. Did you get the correct answer? If you do, good job! For the third statement, liquids flow because the particles are packed in a very orderly manner. Did you answer it correctly? Very nice! The fourth statement, gases do not have a fixed shape nor volume because the particles are very far apart from each other and they move rapidly in a random motion. Did you get it right? If yes, very good. Finally, the last statement, or number 5 statement, gases can be compressed easily because the particles are held by strong attractive forces. Did you answer it correctly? Excellent! We can learn more if we are using our senses. So let's try this simple experiment. Prepare the materials needed: salt, water, plastic cup or a drinking glass, spoon or stirrer, and see to it that the working area is clean before and after performing the activity. Then read and follow the procedure carefully. But first, let us know our objective. And that is to prove that there are spaces in between the particles of matter. Follow the procedure well to obtain accurate results and enjoy your experiment. Watch the video to help and guide you in answering guide questions.
Let's watch this experiment closely. First, I'm going to start by just filling this cup with warm water. Now I'm going to take 1 spoonful of sugar and add it to the water. With the spoon, I'm then going to stir the sugar into the water. Watch what happens. Let's take a minute to think and reflect. What did you notice happening in this experiment? Let's rewind this and watch one more time. Now this time we're going to think a little deeper. We know that the sugar is staying in the water because after this experiment, if you were to taste the water, it would taste sweet. So this time, as you watch, think about, where does the sugar go in the water? And why can't you see it after it dissolves? Here it is again. We add the sugar, and then after we stir it, you cannot see it anymore. Let's stop for an experiment check. Where do you think the sugar goes? Why can't you see it after it dissolves? Now would be a good time to pause the video and discuss. Ready to find out? Well, to understand this, we need to look a little more closely at the water and the sugar. If you took your spoonful of sugar and zoomed in, at first you would see a bunch of grains of sugar. You can see these with your eyes if you look really closely. But if you were to zoom in even further on just a single grain of sugar, far smaller than what your eye can see, you would see that a sugar grain is made up of tiny, tiny particles of sugar. And it's not just sugar, it's water too. If you zoomed in on this water, at first you would just see more water. But if you kept zooming, eventually you would find that water too is made of tiny little particles. Well, what is a particle? Particles are tiny objects that are too small to see with your eyes. Everything around us is made of particles, even if it doesn't look like it. Water is made of particles, sugar is made of particles, even you and I are made of tiny particles, too small to see. Let's stop for a science check. My friend and I went to the beach, and she picked up a handful of sand. She said, "Look, you can see each grain of sand. A grain of sand is the smallest piece of sand there is." Do you agree with your friend? Is a grain of sand the smallest possible piece of sand? Now would be a good time to pause the video and discuss. So how does understanding particles help us explain dissolving sugar in water? Well, if we start thinking about the experiment in a new way, it might help. Instead of thinking of just adding water to a cup, let's think that we have a lot of particles of water in our cup. And instead of thinking of just adding some grains of sugar to our water, let's think that we're adding together many, many, many particles of sugar. Now, what you can start to see happen is as soon as that sugar hits the water, it breaks into individual particles. Then, when I take my spoon and start stirring it, those particles spread around. Instead of just being on the bottom of the cup, they spread so that they're throughout all of the water. Notice that the sugar particles are now just filling up the empty spaces between each of the water particles. So where does the sugar go? Well, when you add it to water, first the sugar grains break into individual particles. Then those sugar particles move into the empty spaces between water particles. After this, you don't see the sugar anymore because particles are too small to see. You can't see the sugar particles in the water. Let's stop for another science check. Sugar dissolves because both sugar and water are made of. After it dissolves, you cannot see the sugar because. That's all for now. Stay tuned for next time.
Did you have fun doing the experiment? Great! Get a piece of paper or science notebook and write your answer to these guide questions. For number 1, did the level of water arise in the container after adding salt? 2, why do you think the level of water did not rise? Support your answer using the particle model of matter. We will now sum up what you have learned in this episode by doing this activity. Fill in the blanks with the correct word to complete each sentence in the paragraph. Write your answers on a piece of paper. 3 minutes will be given for you to do this activity. Did you get all the correct answers? Excellent! Compare your post-test score with your pre-test score. How well did it go? Did it went well? Good for you! That ends our lesson about the particle nature of matter and its properties, and I hope you have learned something about it. Once again, I am Ma'am Roblyn Evina, your science teacher, and thank you very much. Goodbye and stay safe always.